Sorry I can't be with you today. So I've done a video for you with very clear diagrams so you can get your head around this final part of the forces bit, which is higher level and mainly in triple, which is about drawing vector diagrams. So by the end of this lesson, you'll be able to recognize that forces can be shown using scale drawings. You should be able to use scale drawings to find resultant forces. You should be able to use scale drawings to resolve forces into two components, and also use scale drawings to find the resultant force of more than two forces. We are not doing, that is not part of GCSE. So, first of all, it's actually very easy. It's rare to find a single force acting on an object. So objects normally have at least two forces acting on them. We just do two for these diagrams. But it's really simple to work out the resultant force if they act in the same plane. So the resultant force of those two is 10 newtons acting that way. But it's much more complex when they're not acting in the same plane, for instance, at this angle. So what we can do is we can draw a vector diagram of this. We draw these two to scale, but you can see that what I can do is I can use a parallelogram. So if I draw this vector at the end of this one, you can see I've drawn a parallelogram, and what I can do is I can join the start of that to where I've ended here, and the length of that is the resultant vector, and of course I can also measure the angle. So that's called the triangle rule, which you can use. So the key thing is you draw one vector to the right length on a scale, you then join the next vector up top to tailing it, and then you draw the resultant vector by joining the start to the end and measure that length and use a protractor to measure the angle. It's really important when you draw these that when you've drawn that to the right length, you don't sloppily put an arrow on the end, because you will increase the length. And in your exam, there will be a range of values for this length. And if you're outside that value because you haven't drawn accurately, you won't get the marks. So you have a practical sheet which looks a bit like this. I'm going to show you how to do the first one very carefully on the video, which comes up next. Then I want you to have a go at those ones. So we're now onto these ones, and these diagrams are ones where they're not at right angles to each other. So I'm going to show you how to do this one in detail. Then I want you to have a go at that one and the others, and then your teacher will be able to play the video where I've speeded things up to show you the answers to those ones there, and then we've got a plenary afterwards. So finally, these are exam practice questions. I want to do the first one with you, and the issue we have is that these in your exam will be exactly the same scale as your ruler. This will be an exact centimetre. I'm going to show you how to do the first one, and I made a mistake because instead of 60 newtons, I drew 600 in a rush. But you'll get the idea how to do that. You do it correctly once I've demonstrated it, and then you can then pause the video, and then your teacher will then play the video again so you can check this one as well. Thank you. So I've got to draw a vector diagram of these forces. Now, because they're only 4 newtons and 2 newtons, I'm going to double the scale to make sure the diagram's accurate. So first I'm going to do is I'm going to draw a horizontal length of 8 centimetres, which will represent 4 newtons. Secondly, I'm going to have to draw a vector at right angles to this. So to make it accurate, I'm going to use my protractor to put a dot on the diagram so I can produce a right angle triangle. I've got 2 newtons, so I'm going to draw 4 centimetre length of diagram. I'm going to put arrows at both ends, making sure that the arrows don't lengthen anymore those lines. I'm going to label both of them, and I'm going to join the vectors up So I'm going to start where I started at the start of the 4 newtons and I end at the end of the 2 newtons, and that is my resultant force. Put an arrow on that, and if I measure the length of that force, if I measure it with centimeters, it's 9 centimeters, but that was on the scale, so divided by 2 gives me a vector of 4.5 newtons. So now I've shown you what to do, move on to these ones here, and then also complete as many of those as you can. Don't go on to 4 yet. I want to explain how to do that, and your teacher will pause the video and go back over it in a minute or two. Because these forces are larger, I'm going to decide to use a scale of 1 newton to 1 centimetre. So I'm going to first draw the 4 newton force acting to the left, and that's going to be 4 centimetres long. It doesn't matter which force you draw first, you will still get the same result. Once I've done that, I'm going to draw, use my protractor to get a right angle, and I'm going to draw 6 centimetres down, representing the 6 newtons. Finally, I'm going to join those two vectors up and draw the arrow which way that resultant force acts. Measuring it, it's 7.2 centimeters, so it's 7.2 newtons. The next one, I'm going to choose a scale of 1 to 10 newtons. This one, I'm choosing a scale of 1 centimeter to 1,000 newtons. I know I've said 1 on the diagram, it's 1,000. So now have a go at 2 and 3, and I'll explain 4 in a minute. So for 2 we have to interpret what it says, and so we've got 3 newtons acting to the left and 5 newtons acting down. So I'm going to use a scale of 2 centimeters to 1 newton because they're quite small forces. This gives me a length of 11.6, which is 5.8 newtons. So I've got 20 newtons acting up and 50 newtons to the left. I am going to use a scale of 2 centimeters for 10 newtons. So length is 10.8 centimeters, which is equivalent to 54 newtons. So we're now onto these ones, and these diagrams are ones where they're not at right angles to each other. So I'm going to show you how to do this one in detail. Then I want you to have a go at that one and the others, and then your teacher will be able to play the video where I've speeded things up to show you the answers to those ones there. And then we've got a plenary afterwards. So finally, these are exam practice questions. I want to do the first one with you, and the issue we have is that these in your exam will be exactly the same scale as your ruler. This will be an exact centimetre. I'm going to show you how to do the first one, and I made a mistake because instead of 60 newtons, I drew 600 in a rush. But you'll get the idea how to do that. You do it correctly once I've demonstrated it, and then you can then pause the video, and then your teacher will then play the video again so you can check this one as well. Thank you. Finally, the next vector diagrams take it a bit further because your vectors are not at right angles. So I'm going to first of all use a scale which is 2 centimeters per 1 newton. So first thing I'm going to do is to draw the 4 newton vector, and I'll make that 8 centimeters long. I now need to draw the 5 newton vector at an angle of 70 degrees to the horizontal, starting from the end of that 4 newton vector top to tail. So I'm going to use my protractor to mark 70 degrees, put a dot, and that will give me the direction. I'm now going to draw 10 centimeter line to represent 5 newtons at that angle of 70 degrees. Finally, I join the two vectors up, and on my scale 14.8 centimetres, which is 7.4 newtons. The last thing I do is get the protractor and measure the angle of that vector to the horizontal, which is 40 degrees. So this one, because the values are quite small, I'm using a scale again of 2 newtons per centimetre. So I first draw a 6 centimetre line, which I should have labelled 3 newtons, not 6. Next I have to measure an angle of 80 degrees at the end of the first vector. I then draw a line 10 centimetres long to represent the 5 newtons. Finally I draw the resultant vector. I make the length 12.8 centimetres, which is equivalent to 6.4 newtons. Lastly, I use the protractor to measure the direction of this vector, which I make 50 degrees to the horizontal. For the last two, I'll just let you watch me draw these in fast motion and you compare your diagrams to mine. I'm going to use a scale of 1 centimetre to every 1 newton for both of these because they are quite large. So finally, these are exam practice questions. I want to do the first one with you, and the issue we have is that these in your exam will be exactly the same scale as your ruler. This will be in exact centimetre. I'm going to show you how to do the first one, and I made a mistake because instead of 60 newtons, I drew 600 in a rush. But you'll get the idea how to do that. You do it correctly once I've demonstrated it, and then you can then pause the video, and then your teacher will then play the video again so you can check this one as well. Thank you. Finally, these two exam questions. They haven't been photocopied 100%. In your exam, when you see these graphs, they will be exactly 1 centimetre. So you'll be able to measure the resultant using your ruler because it will be the same. For us, because the scale is different, I'll show you how to do this on your diagrams. The key is to do a sketch above so you can think about which way the arrows go, the vectors, and also make sure your starting vector point allows you to draw the whole thing to the correct scale without going off your graph paper. So I'm going to use a scale of 1 centimetre on the graph scale equals 100 newtons. So I need 3 whole squares down. Sorry folks, in my rush to do this morning, I've actually drawn it 600 newtons rather than 60 newtons, but you get the idea. So I've got to draw it 6 centimetres long for that 600 newtons. You do it correctly. I'm then going to draw the resultant vector and put an arrow on to show its direction. Because this photocopy is not the same scale as my ruler, which it would be in the exam, I'm going to measure the length of that line and then put it against the scale to work out how many centimetres it actually is. So that's 6.6 centimetres on the graph scale, which is 660 newtons. Finally, measuring the angle to the horizontal gives me 26 degrees. Sketching again the vector at the top allows me to visualise it. I've got 150 newtons acting to the left and I've got only 50 newtons acting up, so I need to start towards the bottom of the graph paper. I'm going to use a scale of 1 centimetre equals 20 newtons. This means 150 newtons is 7.5 centimetres on my graph scale. Next, my vertical 50 newtons is only 2.5 centimetres on the scale of the graph. I now draw the resultant vector and put the arrow on it and measure the length with the ruler. Again, in the exam, if the photocopy scale was correct, which it would be, that would be my length. But I've got to just measure that length and go down, and I make that the full length of the graph paper, which is 8 centimetres. So that means that the force is 160 newtons. Finally, the angle measured is 20 degrees to the horizontal.